Hello everyone, welcome back to the problem solving session. This is the problem number 59 from chapter 24 of Halliday Resnick Walker. In this problem it said that a particle, charged particle, either it could be electron or proton, is moving towards the rightward between the two parallel charged plates separated by a distance d, where d is 2 millimeter. The potential are V1 actually minus 70 volt and V2 50 volt, and the particle is slowing from its initial speed of 90 km per second at the left plate towards that. Now the question they ask is the particle are electron or proton, and what is the speed just as it reaches the plate 2. So fine, it say that, look at this, the given information on that, your potential of the plate V1 actually minus 70 volt and V2 actually minus 50 volt. It means that V2 is high potential with respect to the V1. If it is high potential, then we can say that the electric field would be towards that direction, right? Since V2 actually minus 50 volt and V1 actually the minus 70 volt, then that the direction of that electric field. Fine, so that means electric field would be from right to the left direction, high to lower potential basically. Fine, now, and this charged particle is slowing down towards the left with the initial speed. The initial speed of the charged particle actually 90 km per second, which we can write 90 into 10 to the power 3 meter per second. It's slowing down. If it's slowing down, so that means this particle could be basically a proton, since the proton should move towards the direction of that electric field. Then it would be accelerated, right? If it moves towards the direction of the electric field, it should be accelerated. Since it's slowing down, that's when it is going to be deaccelerated. So that's why I can say that particle is going to be basically proton. So from there we can write, since the particle slowing down, that's when it is deaccelerating, slowing down, so the particle would be proton, right? Since it's moving to the higher potential, that would be the logic. If it is electron, so definitely if it is moved toward that direction, it should be accelerated. So that's why the answer of this first question is with the charged particle would be the proton. Now fine, in the second question they ask what is the speed of the particle just as it reaches the plate 2. So that's mean, since it's slowing down with the initial speed Vi, what would be the speed of the particle when the particle at the reach the just to reach the plate B, plate 2. We can find out using that energy conservation law over here. Energy conservation law, we can write kinetic energy initial plus potential energy U initial must be equal to kinetic energy final plus potential energy final. So kinetic energy initial we can write half of mv I square. So we can say this is actually the Vi, initial speed, plus the potential energy I can write Q into V1, which is the electric potential, must be equal to half of m Vf square. We want to find out that, plus Q into V2. V2 actually the potential at the plate 2. Now we can do some calculation. We can multiply the 2 on both sides. In that case, I will find out vi square plus 2 giving v1 m vf square plus 2 giving to v2. Then we can write from there, it could be m vi square would be plus 2q v1 minus v2 must be equal to m vf square, right? From there I can find out that vf, so vf would be m vi square, which is the speed, plus 2 given to capital V1, which is the potential plate 1, capital V2, which is the potential at plate 2, divided by the mass of that charged particle, which is basically that proton. The mass of the proton that you should know, which is would be 1.67 into 10 to the minus 27 kg. And charge also know that it's a positive charge, right? So the charge of the proton will be 1.6 into 10 to the minus 19 coulomb. Now if we plug in that value over here, in that case the speed, we could find out, if we plug in that value, mass is 1.67 into 10 to the minus 27 into v square is 90 into 10 to the 3 square plus 2 the charge, so 1.6 into 10 to the minus 19 coulomb into v1 is negative 70 minus v2 is minus 50, right? That minus is going to the plus, is going to the 50 divided by mass of this charged particle, which is 1.67 into 10 to the minus 27. So if you solve this one, then you will find out that speed of this charged particle would be 6.53 into 10 to the 4 meter per second. So that would be the speed of that charged particle of the proton when it reaches towards that second plate. Thank you very much.